and I'm an 8th grader, and we're studying the history of the catapult and the Crusades right now. From the time we are toddlers, people tell us to share and share alike. Unfortunately, this lesson hasn't been learned very well by 3 major world religions. Christians, Jews, and Muslims have fought for hundreds of years over the Holy Land, or modern-day Israel. These religious wars we caused are a great deal of suffering and loss of life.
Okay, you can talk about
Right now we are talking about the catapult, one of the major weapons that we used in the medieval times. First thing I'm going to talk about is the history and types of catapults. The 2 types that were mainly used were the mangonel and
the torsion.
No.
The trebuchet.
The mangonel was powered by twisted ropes and was powered by torsion. The trebuchet was powered by weight in a kind of a seesaw-like action. Then there was another. Then the torsion is basically twisted ropes.
You can show.
And stuff.
You can show.
Right over here, this is a torsion catapult. This is an example of one. See the twisted ropes right here? When I pull this, it'll want to go in circles, but this block right here is stopping it from doing that. See? And we made several of these in class. This type of catapult is known as the mangonel. Trebuchet is usually very large and has a weight on one end, and when the rope is cut on the other end, it moves down and launches the rock very far. It's usually used to take down fortresses, trebuchet, since it's much bigger.
Or any projectile that works.
Yes, and the mangonel was basically to take down armies in the field, since it shot much smaller rocks.
So what did you learn during this project?
I learned that kata and catapult means downwards motion.
And pelties means to sway a projectile. So kata means downwards motion, and pelties means to sway forward a large missile. So that's where the word catapult.
What they were using rocks back at the time, wasn't it?
Yes,
missiles?
Rocks. Missile means a flying object.
Okay.
Projectile. But anyways, science of the catapult had to do with Newton's laws. One of the most important is any object at rest will remain at rest. Any object in motion will remain in motion unless acted upon by an outside force. In this time, the outside force would be gravity while the rock is being flied, so it would only be stopped by the gravity of the object. And then there is the kinetic and potential energy. You see, whenever the catapult is down, since it's wanting to move up, it's scanning potential energy, which is the energy of position. It's charging up energy. But once I release this, all that goes into the energy of motion, which is kinetic. And because of all that potential down here, it moves, and all that kinetic energy is transferred to the rock.
And it creates a forward motion.
Yes. And then that's kinetic and potential energy. And now the math is the weight of the rock. The weight of the rock was usually very important, because if it was a lighter rock, it would usually go farther. But if it was a heavier rock, it would go a shorter distance, but do a lot more damage. Torque was also a very important structure. Depending on the amount of torque, which is the amount of energy supplied in the twisted ropes and force, that could shoot a rock farther if it was smaller, or a smaller rock longer distance, depending on the size of the catapult as well. Then there's the literature.